Vice Chancellor, Anna University, Professor Velraj, the Director of the Center for Research, Dr. C. Umarani, specialist and entrepreneur in AI who has run the workshop yesterday, Jyoti Perisamy, Professor Valerie Vodosov of Tallinn University, the Registrar, Dr. J. Prakash, who is to deliver the vote of thanks, the many delegates from around the country, around the world. I don't think there are many students here, but if there are, the students as well. Ladies and gentlemen, good morning and thank you very much for inviting me to be a part of this event in the course of a 3-day international conference with a couple of days of pre-conference workshops already completed. I'm not sure I'm the right person to talk anything about the topic, because if the topic is research trends, I must say that I'm very far away from research, being in public service and in electoral politics. But given my personal experience, both in what I will call the precursor of IoT, as well as how much AI is going to transform the nature of technology and its applications, and mostly because I served as a consultant, as an industrial consultant, starting as a graduate student, I think in about 1990 or 1991, for a decade or more before I went back to business school. I have some thoughts about how I think these technologies are going to be applicable and likely to impact both the infrastructure business as well as manufacturing and other industrial activities. People of my age are here, so I don't have to remind all of you, but some of you are quite young. But let me remind you of the many revolutions in technology, in information technology, that have already happened in the last, let's say, 40 years or so of my adult lifetime. I had the good fortune of receiving one of the first IBM PCs made in the year 1980 or 81. Somebody brought one back from the United States for us. And it was a revolution, because for the first time, individuals could actually use a machine to do calculations, to print things, to design, to do so many tasks that till then could be only done with a typewriter or by hand. For those of you who remember, back when I went to graduate school, the bulk of computer processing happened either on mainframes that required you to do a lot of thinking, writing code, getting those converted to punch cards, and then get the punch cards fed into the machine when you got your slot, and then you'd wait for the program to run and give you back the output, and then you'd get the output like 6 or 8 or 12 hours later. That's what mainframe computing was like at universities, at research institutions. There was no email, there was no internet. Maybe there were mini mainframes like wax machines, and the inception of desktop workstations on Unix like Sun Microsystems. This was late 80s. So we went through a few different revolutions, starting with the PC. In my opinion, another major revolution was the onset of graphical user interfaces, whether it was Apple Mac or the first Microsoft Windows release, I think in 1990, because it truly democratized access, where you didn't need to have learned a programming language just to operate the computer, let alone to do anything more with it. I think I was one of the first people to complete my entire PhD dissertation on a personal computer without having to go to any major text editing programs on a workstation. And I used, at the time, I forget what it was, but it was a software that could run on a PC to format and actually, frame my entire dissertation of a few hundred pages with tables and graphs and whatnot have you. And then, in my consulting days, I saw the advent of both thin clients and very relatively then very sophisticated and very cheap analog to digital signal converters, which was the basis of the whole ERP revolution. For many of you who may not remember, it was only in the early to mid 90s that ERP solutions started becoming standard, right? I2 and things like that, long before there was the SAPs and PeopleSofts. So really, if you start with the notion of integrating physical activity to some centralized computer control or automation or planning or strategy or critical path, then the ERP revolution was the first major computerization of industry, where you could start integrating all the way from your order book or your customer demand to how your factory should schedule production of what variant of what product. So this was maybe 30 years ago, mid-90s. Of course, connecting everybody together and creating the internet was another huge revolution in the mid to late 90s, leading up to the first dot-com boom and bust. And then we have had multiple comings of artificial intelligence. This is not the first coming of artificial intelligence. We've probably had 3 or 4 of them in my lifetime, where the neural networks and whatnot have you. And of course, now we have been in a boom since the age of social media. There's been, in many ways, a negative revolution or a deeply societally impactful revolution where you have started to create mini ecosystems of extreme views, and both society and politics as a whole has become greatly polarized. And I, for one, think that social media had a huge impact in the degradation of the quality of politics in most democracies. And I'm not the only one. I've been to a few conferences recently, and I'm starting to see more and more people talk about this. In fact, I spoke at a conference in Delhi last week, right after our Imagine conference. I had to fly up the next day to keep a previous commitment, and the gentleman who spoke before me was the author of a book called The Outrage Machine. And it talks about how social media has created this rage in society because of continuously feeding the kinds of messages that are likely to invoke extreme feelings and anger and passion. And so, we have seen negative kind of innovations and revolutions as well. But if I think about 2 things, 1, IoT, and 2, AI. Let's look at IoT first. In some sense, IoT is a progression of general purpose technologies that started with the notion of steam or electricity, which were useful in a myriad of applications and could effectively increase efficiency, increase throughput, increase economic value with the application of one general purpose technology across a lot of things. And IoT, at least in my kind of jaded view of the world, perhaps based on the many things I've seen in decades, is simply that we now have, instead of having an AD converter, get some kind of input, take it to some other place, process it somewhere else, and then send back some feedback or try and control the machine. Now we can embed that intelligence into the machine itself. We can have actually connected real-time systems with localized optimization and localized intelligence or localized programming inside the devices. So I don't need to wait for a machine to go and get integrated with other machines. The machine can A, take care of its own logic in its own embedded chip, B, talk to the 2 machines up and down the line without having to go to a central server and get optimized internally within this mini component of the assembly line of process, integrated process. In industry and infrastructure, this is likely to be only a gradual or a step change rather than a revolution. But in our daily lives, I suspect that if we really connected all our devices through these kinds of things like smart fridges and whatnot have you, lighting systems, heating systems, etc., I think we'll be seeing revolutionary outcomes, both in terms of efficiency, cost, as well as actually optimization of quality of life. It's not quite here yet, but my suspicion is that it's not very far away. Moving on to AI, as I say, this is the third or fourth or fifth coming of AI. The cutting edge of AI is very, very impressive, and it is in a different league now, because if I put that in context, my PhD dissertation going back to 1992 or 93 was about understanding how people think and trying to figure out how to make the machine slightly more user-friendly to people. So it was titled Individual Differences in Cognition and the Implications for Computer Interface Design. That was my PhD thesis, I'm saying late 80s, early 90s. Here we are, 30, 35 years later. We don't really need to worry too much about machines. We now are designing machines to understand how people think and to actually act in a way that is natural for people to interact with. This major shift away from trying to get people smart enough to work with machines to making machines understanding enough to work with humans is really driven by, in my view, two core things. One, the almost infinite capacity to generate, store, analyze, and learn from data, which is not a small thing back in the day. Just to put that in context, I should also tell you, the first IBM PC that I got had 64 kilobytes of RAM and a 20 megabyte hard drive. 20 megabyte hard drive, right? That was the size of memory storage then. I think my phone has like a few hundred GB of storage. So you can see how much the world has changed. So this capacity to have, terabytes and terabytes of data instantaneously generated, analyzed, stored infinitely, in flash memory, because then you didn't even have the kind of storage devices that were that permanent. Those of you who are my age may remember floppy drives and mini floppy drives and whatnot have you. So the first engine of the AI, revolution, this revolution has to be the capacity to generate, store, analyze previously unimaginable quantities of data in many forms, not just text form, but increasingly voice as the medium of data and storage. And the second has to be the sheer computing power or the computing efficiency, transcending all the notions of Moore's law, the capacity to now, process information through what once used to be called supercomputers can now basically be hired on demand through the cloud by even a startup. And so your ability to get actual processing capacity has been democratized to some extent, and innovators can really get access to equipment that would otherwise cost hundreds of millions of dollars. So the good news is that if you're an innovator, if you're out of the box thinker, you can get access to these things much more easily and with fewer barriers to entry than there used to be. But there's some, reality checks we need to go through. At this point in the world, there are relatively few people who can make the kind of high-capacity processors like the GPUs. I just saw the earnings statement. How many of you saw the last earnings statement of NVIDIA? NVIDIA last quarter had record profits of $17 billion for the quarter, not for the year, for the quarter. Now we've got a problem. If you need NVIDIA chips as the basis for any of your plans, I think the waiting list for supply is something like 3 years long. And big companies like the Microsofts, Googles of the world are just acquiring them like they're going out of style, partly because it's a roadblock to others who might otherwise come and compete in the business. So there is a serious supply chain constraint. Of course, there are many more companies who are coming up with competitive chips. This relatively monopolistic advantage will not last forever. But just to tell you, just because the cutting edge of the technology is at one place, doesn't mean that everybody has the capacity to do it at that scale continuously. I read somewhere that ChatGPT's, OpenAI's monthly cloud processing cost is something like $25 million, right? That's how much they pay for the processing on the cloud. That's one company, agreed, 100 million users or whatever, but still. So Though the leading edge of the technology might be very advanced, it's not nearly available to everybody, at least not steady state. The other thing is, even though we have such capacity to store and process data, and even though I would say in Tamil Nadu, we are lucky, one of our most booming industries is new data centers for various reasons. It is still a far cry from the amount of storage that is going to be needed to really make this kind of technology available to a lot of people, and the amount of resources from electricity to cooling that are going to be required to make this happen. So, in my mind, we are still in the very early stages of this era, this S-curve, this transition. And I don't think it's going to come as quickly. Maybe the leading edge moves rapidly. Already we are starting to see some limitations in the leading edge and the extent of hallucinations and stuff that come out of ChatGPT. So I'm not sure that this leading edge will even move as rapidly for the next, let's say, 36 months as it has for the last 12 months. But even if it were to, it's not clear that it would be scalable because of the physical limitations, the infrastructure costs, and the access to the supply chain and the manufacturing of these devices. In a way, that's good, because what it does is it allows people like us, people who are rich in human capital, which Tamil Nadu is almost unlike any other place in the world, to tailor our education, improve our understanding, increase our connect, and bring the best and brightest in the world to help us shape a different approach to the development of talent for this new era. This new era will probably take 15, 20, 25 years to reach its potential. And therefore, we have the luxury of scale, because we're almost 75, 80 million people, but also of the raw talent. We must have the highest per capita tertiary education enrollment ratio in India by a lot. I think the second state is Kerala after us, and it's about 10 percentage points below us. So we have this talent that is shapeable and a pipeline of talent that is hopefully getting the right kind of education. And if we start shaping the curriculum going back to the higher schools, the secondary schools, the elementary schools to match this new notion of what we should actually be specializing in, then I think that Tamil Nadu is poised in a very wonderful position to benefit from this. I just want to mention one thing. When we had this conference, I had the great luxury of listening to a lot of leading minds in the space, from big companies, from startups, from companies, from creators who have created unicorns, from listed companies worth billions of dollars. And one of the things that I really took away was a friend of mine sent me a clip of Jensen Huang, the CEO of NVIDIA, speaking at Davos this year. And he said, everybody here is talking about, I got to get my youth and my children into computing technology, and everybody should become a computer scientist, and AI is going to make everybody depend on, learning computing. And he said, I go completely opposite. He said, as far as I'm concerned, that's our job. That's what these machines are trained to do. We will make the machines. You educate your children on understanding a field really well, biology or agriculture or accounting, something. Let them figure out where are the issues, what are the problems. Let them understand the limit of the science. The machines will take care of the computing part and the programming part by themselves. That's what AI actually promises. So in that sense, I would say, though it is a different era, some things are the same. And as I was speaking to Mr. Perisami here, he said he had been teaching some things at Sloan where I studied. Last November, I went on a tour of universities in the US with my son, my younger son, who was getting ready to apply. And by coincidence, I'd already had some pending engagements to give lectures. So we went on a 6-university tour, and I spoke at MIT, at Harvard, at Chicago, at Brown. And then just for his sake, without speaking, I also went to Yale and Columbia. And it's amazing to me how many of these institutions, especially the ones like MIT that we always see as technology-based institutions, how many of them are pivoting back towards the humanities. In fact, at MIT, in the college tour, in the campus tour introduction section, what they said that was striking to me was that even if you're going to pursue something very sophisticated like nuclear physics, if you are a MIT student, for the first year you have to take 5 courses in the humanities. Otherwise, you'll not get your degree. Right? I mean, here we are getting more and more technologically sophisticated world, and they are really focusing on understanding the basics. Be a cultured person, be sensitive, be thoughtful, understand history, understand art, understand psychology, and this is the basis for having a sustainable career, because what is cutting edge today will be passé the day after, and new things will keep coming, and those who actually understand to be learned people and to learn continuously are the ones who are going to be long-term successful. So, when Chicago, which most of us see as a very strong economic school, says, no, no, we are a school of the humanities, or MIT, which we all see as a technology institution, says you must study the humanities, then we understand that, even in a changing world, some things stay the same. And we should remember our philosophy, which has helped Tamil Nadu be one of the best states in the country, which is inclusion, access, social equity, justice, and education for all. So I hope this conference held at this premier institution of our state's technical education scale and scope will lead to more minds being exposed, more ideas being created, more development being accelerated, and most of all over the next few days that all of you will make new friends, have fun, learn, and have the joy of participating. I thank you very much for inviting me. I hope you have a wonderful conference.